Hello, friends. In math class, people see equations a lot as they're learning math, and then all of a sudden they're introduced this idea of a function, and they get all freaked out. But a function is actually really, really simple. I'm going to explain it to you right now. What is a function? So here's how I want you to think about a function. It's actually very, very simple. It's just an input-output machine. You put something in, and then you get something out. And for every one thing you put in, you get one thing out. So, for example, if you put in a circle, you can get a 5 out. If you put in a triangle, you get an 8, or a square, you get a 5. This is a function. It seems like a very silly function, but it's the basic idea that there's some input and there's some output. And this works as a function because for every one thing you get in, you get one thing out. Now, in this function, we do have two different things giving us the same thing, but again, that's okay. What we're concerned with is that every one thing we put in only gives us one thing out. If we put one thing in and then it keeps giving us different things, like in this case, if we put in a circle and then it gives us either a 5 or an 8, that doesn't work as a function. Okay, so just very, very basic. A function is just an input-output machine where every input has only one output. Now, the way that this is most commonly expressed is with graphs. Okay, and so there's an example here. One example of a function would be y equals 5x minus 3. Okay, and so in this case, the idea here is that the x is the input and the y is the output. Okay, so again, x is the input, y is the output. So if you put in 0, you're putting in 0 in for x, then what it gives you, this is telling you what the rule is, how you get the output depending on what the input is that you give it. So you put in 0, and then you perform this calculation, and you get negative 3. And we see that here, when we put in 0 on the graph, negative 3. So all we're doing is a graph is an expression of the input, the horizontal is the input, and the vertical is the output. Okay, and so input 0, output negative 3, and that gives us this point right here. Now there's an infinite number of inputs and an infinite number of outputs that result from this kind of function. And the input-output combination is this line. This line tells us what the input-output combination is. And so, for example, if you put in 5/3, if that's the input, this function, again, tells you what to do with that to get the output, and that gives you this point. So 5/3 comma 0 gives you that. Okay. Now here's another example of a function. Okay. X squared minus 2. Again, x is your input and y is your output. So if you put in 0, then your output is negative 2, right? You plug in 0 for x, you're left with negative 2. So that gives us the point 0 comma negative 2, which is right there, known as the vertex of the parabola. If you put in radical 2 or negative radical 2, that gives you 0. Now again, remember, the rule about a function is that every one input gives us only one output. We can get the same output from different inputs. That's okay. It's still a function that way. But it would be, so this is still a function, even though we're getting the same output for different inputs. Okay. When in graphing, what we call the vertical line test, if we draw a vertical line, we have to hit the function, the line, the curve, whatever it is, at only one point. Why? Because a vertical line represents one input. And so for every one input, there can only be one output. And in this case here, like what I drew, there's only that point, and that's it. So this is another example of a function. All right, so graphs and these types of XY equations are just examples of input, output. Okay. Now here's another one. If we write this, y equals the square root of x. Now this doesn't work because if we put in 25 for x when we solve this, right, the square root of 25 is positive or negative 5. Because if you take positive 5 squared, that's 25, but also negative 5 squared is also 25. So this is an example of something that is not a function. Why? Because this one input gives us two different possible outputs. So that's something that's not a function. Okay, some other examples of functions. Normally you'll see things like f of x. Okay, so all this is telling you is that we have a function and that x is going to be your input thing, and then this is a function that you're doing on x. So whatever the input is, it's doing something to x and giving you a result, the f of x. And this is an example of the one that we saw before. Now realize we can put any letters in here. It doesn't have to be x, doesn't have to be y, doesn't have to be f. We can use t, for example. So I'm a physics teacher. We use t a lot for time. Right? So we have g of t. So this is telling you that this is a function where t is the input. T is the thing that we're putting in, and then g of t, that's the output that we're getting. These two are the same operation. We're just using two different letters. Right? So don't let it throw you off. In physics class, a lot of students come in, they see different letters all over the place, like T and H and E, and it throws them off. We can use any letters we want, but it still means the same thing, and the math all still works the same way. Another thing that people get thrown off by sometimes is what are called trigonometric functions. So these are functions that have to do with angles in triangles, mostly right triangles we start with, and then we get these ratios out. So theta, this thing here, that's the Greek letter theta, is the angle. So what this is telling us is that if we put the angle in, some angle measure, then it gives us a ratio out. So here's an example, r of theta is cosine theta. So again, a trigonometric function like sine, cosine, tangent, those are just functions. Again, just input, output, where you put in an angle and you get out a ratio. Okay. And then as a physics teacher, here's examples of a couple of physics equations that my students might see where, you see that there are no, we don't see x, we don't see y. Instead, what we see here are v's and t's, at least in the first one, right? What does this mean? T is the thing we're putting in, and in physics, the letters actually mean some physical quantity most of the time. And so t in this case is time. This is telling us that we put in the time goes in, and then we can do some calculation, and then whatever comes out, whatever the output is the velocity at that time. All right, so this is actually the equation for if you take a ball and you throw it up into the air at 50 meters per second, this function will give you roughly the velocity of the ball at any time later. So 5 seconds later, if you put in a 5 for t, then you get the velocity of 0. So it reaches the height of its path 5 seconds later. So we have these useful functions. Also, we have general forms of equations like this one. Notice now we've got no letter. There are no numbers. There's not a single number. It's all v's and t's and then this a. So how do we know what the variable is? How do we know what the thing that's in there? Again, v of t. T is the input. So v naught and a, or v sub 0 and a, these are two constants. We don't necessarily know what they are. They could be anything. In the equation above, they were 50 and negative 10. But in this case, it's just v naught and a, and those are constants. The variable, the thing that's changing, the thing that would be on the horizontal axis of the graph is the t. And what's the thing that results from this is v. And so that's a summary, basic introduction to functions. Again, the key thing I really want you to remember is that it's just an input-output machine. For every one thing you put in, you get only one thing out. And that's what makes something a function. So I hope that helped a little bit. Thanks for watching. Please like and subscribe.